So this is lesson the 40, 58, 98, or 59, 98, kind of day 2 stuff.
59.
It's got several different things. Logs, day 2, or day 3 technically if you count 26 I think it was, as day 1. So this is our second in a series here. This should be the last video of all the stuff that we need to know of logs. So yesterday we did our 3 properties, or 3 laws of logs, that when you multiply numbers inside a log, you can separate them to their own by
Evaluating.
adding.
Adding.
If you are dividing numbers inside a log, you can separate them by a subtraction sign. And if you have an exponent on a log, you can move it out front. And, of course, all of those laws go in reverse. So therefore, if they're added, I can multiply them inside. If they're subtracted, I can divide them. And if there is a coefficient in front of a log, it can go up and become an exponent. Yes? Those are all things that we talked about yesterday in that video. And we ended on inverses. And if we can go back here, we did this. And I'll clean that up. That basically said that if I had a base b with an exponent that was a log with the same base, those would cancel each other, and what was ever in that position for that log becomes the value, because they simplify. They cancel each other out, they're inverses. And the same thing if I have a log with a base that has an exponent with the same base in it, the exponent is the answer. So the first problem we have here is a base 3 that has an exponent that are log, but it's actually 2 logs, separated with a plus sign. And it happens to be both of those logs are base 3. We actually can do 2 different things on this one. We can combine the logs. Do you guys agree with this? And what happens when I combine those logs? You multiply the 4 and the 5. So let's do that. So that'd be 3 to the log base 3 of 20?
Yeah.
Because 4 times 5 is 20. And at this point, the bases are the same. You have the log. What will happen? They'll cancel, and the answer is 20. What if I told you that's not the only way? Wait, what 4? The 4 is incorporated to the 20 because when you add logs with the same base, you can multiply their numbers inside a single one, right? Rule number 1. Now, what if I said you had exponents that are added? When do we ever add exponents? It's because we took something with the same base and multiplied them, right? So would you guys be okay with separating that? Would it be okay to say this? Could I say it's 3 to the power of log base 3 of 4 times 3 times log base 3 of 5? If I multiply those bases, I would have to do what to those exponents? Add them. And so, therefore, in reverse, I split it to its own base, but it has to be multiplied between them. Now, wait a minute. Doesn't each one of those separately cancel each other out? So, the first log would cancel. The second log would cancel. I'm left with 4 times 5, which is still 20. It still works. Either way you want to do that, it works. It's awesome. It's cool. Are there any questions on that? Next problem. Log base e of e to the 14. Does it really matter what's a base? You guys remember what e is? It's a long number. It's like pi. It's an irrational number. 2.718. La-di-da-di-da-di-da-di-da. Never ends. Right? It's Euler's number. We use it for a couple different things. When we're doing exponential growth and decay, we've used it, or they would use it for financial stuff, for money. Doesn't matter what it is. The bases are the same, so the answer here is 14. We're actually going to deal with log base e soon.
Wait.
So the answer is just 14 because the bases will cancel each other out.
That's not a base.
E is a base. Just like before, we've done it with variables like a. Now guys, E stands for a number. The rest of the variables, E and pi, stand for numbers. Everything else just would be a variable. It doesn't matter what the base is, as long as the bases are the same, they'll cancel each other. And again, taking a look at log base 5 of 25, we dealt with this yesterday. How do I make that work?
Put a 5.
What's 5?
Base of 5.
Base of 5. So 25 is what? 5 what? 5 squared. So change it. So this becomes log base 5 of 5 squared. And now they cancel, so the answer is 2.
They just put a 5 up front.
We can put a 5 up front.
They just put a 5 in front of the log.
You cannot put a 5 in front of the log because that would change the problem. You can move the 2 out front, but then you would have 5 to the first, so then it'd become 2 times 1, which is still 2. That's okay. The next thing we need to do is talk about the 2 different types of logs. There are 2 types of logs that your calculator actually has. There's log base 10, and there's log base e. There goes that e again. Now we're bringing back the e thing and actually saying that some of our logs will have an e as a base. And it's pretty often it will do that. So what is it? Well, in a lot of our problems, guys, since we, back in the day, I guess now we have calculators that can probably do this a lot quicker, more efficiently. We can handle things. But back in the day, before they had that, and they had to use slide rulers and all of those things, they like to write things in log base 10. So everything was based off of 10. 10 to some power equals a number, right? So what they did is they didn't want to keep writing this over and over and over and over again. And so they said, you know what, we're going to call that, we use it so often, we're calling that the common log. And so now we're just going to omit that little 10 and just write log. So instead of log base 10 of x, we're just going to say log of x, or log of 5, log of 25, whatever it ends up being. Okay? We're going to get rid of the little 10. So from here on out, if you don't see a base in there, it's implied to be base 10. Easy enough. So if I ask you this, what's the answer? The answer is 2. Why? Because it's log base 10 of 10 squared. The log and the 10 will cancel, and the answer is 2. Easy enough. It just adds another layer onto it. Maybe it makes it a little bit easier to write. Natural log, guys. Well, just like pi is a natural occurring number, so is e. E, we use it quite often in math. And so they're like, hey, sometimes we have log base e. And nobody wants to write log base e all the time, just like we don't want to write log base 10. So what they said, hey, we're going to change it. And so instead of writing log base e, I'm just going to write ln. That's ln. It's a lower l and a lowercase n. Just ln of x. And when you see ln of x, it's called natural log. So we got log of x, and you got natural log of x. Log of x, base 10. Natural log, base e. Now, how can we take the problem that we just did from before and change it? We saw this, whoops. The problem from before was this, right? I can rewrite that as the natural log of e to the 14th, which still equals 14. The problem we just finished from before is log base e of e to the 14th. The bases cancel. They also could have written it as log base e, or natural log of e of 14 to the 14th power. The natural log and the e will cancel, leaving you with an answer of 14. So are there any questions to that? So you can see how the differences can change things. It doesn't change it. It's just written a little bit differently. So This is if I needed to use my calculator. You guys can put these on your calculator. So I'm going to clean this off. And what if I asked you to evaluate what is the let's do natural log. What's the natural log of 25? So take out your calculators. And there is an LN button on your calculator. There is an LOG button or a log button on your calculator. So what you need to do is find those. Now again, it matters what calculator you have. If you have the old gray box ones where you can only put one thing at a time, you have to put 25 first, then hit natural log. Or if you got the one where you can actually see what you're typing, then put LN 25, hit equals. What do you get? Liam? 3.2188, so 3.22. So about 3.22. What does that mean? What does it mean to have a natural log of 25? Does anybody know? Wait a minute, what were logs again? Logs were a fancy way of showing exponents. So guess what? 3.22 is the exponent on the base e that makes it 25. Everybody, take out your calculator. Well, first of all, take a look here. Would you guys agree that that would be a base e? Yes? So let's switch it to exponential. E to the 3.22 is equal to 25. Granted, it's not going to be right because we're approximating. But what is e? There's an e button on your calculator. What's e to the 3.22? Forward. It's probably going to be 24.99.
25.028.
25.028, okay? So, it works. We are finding exponents when you take logs.
Where's LN? It is technical.
Cool stuff? I think so.
Is that how you do it? Use that for anything.
Here's the thing though. Your calculator only has those two bases on it. There's log base 3. There's log base 5. There's log base 163. Okay? That's not on your calculator. Now some calculators can actually put different bases in. Most of the others can't. And so what do we do to deal with that? We use something we call the change of base. The change of base, guys, takes a log that has an unknown base, like not a 10 or an e, and we change it to any base I want. It works, guys. I can change it to from a log base 3. I can change it to a log base 8 if I wanted to. I could change it to a log base 15. But here's the thing. My calculator only has two bases, yes? It's 10 or e. So which two do you think we're going to change them to? 10 or e. So the whole idea for using change of base is so that I can actually put it on my calculator. And how you do it is, if you can notice, is that you start off with log base x of a. We change it to log base b of a, so the bigger number, or the value of the number inside the log is on top, and the base number is on the bottom. But it's to the same log now. You can change it to any base you want. But again, like I said, we're more than likely going to change it to log a over log x. Or natural log of a over natural log of x. Those are probably the two you will use because those are on my calculator. We changed it from base, like in our problem, log base 3 of 6. 3 to what power is 6? That's what it's asking you. You could change it to base 8. So I could put log of base 8 of 6, right? Change it. Okay, let's change this one. I could write log base 8 of 6 over log base 8 of 3. Does everybody kind of get that?
Wait, why are you doing 8?
Yeah.
Because I can.
You can do whatever log.
I can do whatever I want. But here's a problem. It wants you to solve it or evaluate it. Do you guys know what base 8 is? No. So why are you using it? Okay? I'm I'm just showing it works. That will give you the right value. But no, let's not use that. Let's use something we know. And that is, again, log base 10 or log base e. So change it to log 6 over log 3. You take your calculator out. Log of 6 divided by log of 3, it will be a decimal.
Where's our
Your log button,
No, it's
1.1.
1 point.
1.63.
Oh, okay, we're seeing a lot more people are saying 1.63. Guys, how do I know if I'm right?
Check it.
Check it. 3 to the 1.63 power, it should be really close to 6.
How do you check it?
Use your caret button or your y to the x button.
It's 5.99.
5.99. So, we are right. So 1.63 is the answer. We were able to take a log, which we didn't know a base, change it to a base we like, and got an answer. Now, wait a minute. Didn't I say you guys could also do natural log? What if I change this to the natural log of 6 over the natural log of 3? Try that once. You should still get 1.63. You get 1.63. It doesn't matter. And if you guys did have log base 8 on your calculator, you would still get 1.63. It's a beautiful thing. Okay, guys. We forgot. I got one more problem up here. Log base 7 of 82. So, what's log base 7 of 82? Let's change it.
Long base 82.
Log, what is it? What do we want to change it to?
Or log 82.
Log 82 over
7. Log 7.
log of 7. So 7 to what power is
2.26.
2.26? Yep. There you go. Check it.
Check it.
Okay? So these are not too bad. Last stuff. Last stuff for this. You guys should have pretty much everything you need to know to solve for logs. Guys, we're going to solve exponential equations. These are exponential equations. 10 to some power of 2x is equal to 52. I think we all can agree that 10 to a whole number power is never going to be 52. You guys agree? Because 10 to the first power, 10 squared, it's already over. Okay? So we know it's going to be between 1 and 2 for the power of 10 itself, and then we got to divide it by 2. We've done some of these problems before. We solved, you don't have to write this down, we have solved this before. We've solved problems like 2 to the x equals 8 because what we did was said, hey, 8 is also a power of 2. It's 2 to the what power?
3.
And so x has to equal 3. We did that a while ago. What we're going to do today, though, is I can't do that. I can't make 52 a power of 10 in my head. I have to do something. And that something is, I have up there, hit it with a log. So you're going to basically take the log of both sides. Because what you do to one side, you have to do the other. So you hit it with a log, and this log, guys, is going to be the log of the base of the exponent. What's the exponent's base? What's 10? The base is a 10. So you're going to take the log base 10 of both sides. Why? Yeah, why would I want to take log base 10? Because what happens with the left-hand side? They cancel or simplify, and the answer of the left-hand side becomes 2x. So 2x equals log base 10 of 52? I can solve this. Guys, log base 10 of 52 is just a number. What is that number though? Guys,
Wait, why didn't the log cancel on the other side?
because they both had base 10. How many people right now are like, oh, wait, that's the log of 52 over the log of 10?
Yep.
Do we have to do the change of base formula?
No.
No, why?
It's already there.
Because it's already log base 10. So just hit, basically guys, you could ignore that it's a log base 10, or say if you recognize that's just log of 52. And if you hit log of 52, what is it? 1.72. Divide by 2. 0.86. And if you don't believe yourself, plug it back in for x, multiply by 2, put it as a power on 10. You should get 52. These are not that bad. Right? We like these. I can do with these.
I could do it. Is 10 to the first power 10?
10, anything to the first power is that number.
Then how is it less than 1?
The next problem. I've got 3 times 2 to the power of x plus 4. Notice that on these problems, our variables are exponents. So we need to get rid of bases. What should I do first? Distribute? No. There's nothing to distribute. That 3 cannot be distributed to the 2. I need to get rid of the 3, guys. Guys, I need to isolate your exponent. You need to isolate your exponent before you solve. So yes means divide by 3. So 2 to the x plus 4 equals, is 350 divisible by 3? I don't think so, because 3 plus 5 plus 0 is 8, and 8 is not divisible by 3. So therefore, it's this. It's still a number. Who cares? I'm going to hit it with a log. Log base 2. I'm going to hit this with a log base 2. Log base 2 of 350 over 3. What happens on the left-hand side? It cancels and becomes x plus 4. And then I can't evaluate that. That's not on my calculator.
You have to do log 350 divided by 3 over log 2.
I'm going to change it from that. It can use log. I'm going to use natural log this time, just to change it up. Natural log of 350 over 3 over natural log of 2. Now guys, what if I didn't have a calculator? What if I said, you guys cannot use calculators on this test? How do I solve it from here?
You cancel out the natural log.
You don't cancel out natural logs.
Why?
I'm going to subtract 4 and call it a day. Because I need to get x by itself. So x would equal the natural log of 350 over 3 over natural log of 2 minus 4. If I didn't have a calculator, that's as far as you can go. If you have a calculator, though, you'd give me a decimal answer that would be what?
6.87.
I'm hearing 6.87. Anybody back that up?
That's before you subtract.
Oh, before you subtract the 4, okay. Minus 4, so it's 2.87 is what we equal. Does that make sense, guys? Okay, so at this point, you should be able to handle, I think, 99, 98% of those packets. I think there's only one more type of problems that I think I'll make a video for, but we're not there yet. Give you guys some time to digest it all. So, for your homework, guys, is basically finish as much as you can get through. If you get stuck on a problem, move on to the next one. Put a mark next to it. We'll take some questions, okay? Have a great day.